I would like to welcome all the attendees this morning and welcome to the IFM webinar on the Ioke device. My name is Johan van Niekerk and I'll be your host for today's webinar. Important, please note that the webinar is being recorded and we will make it available to view on our website. We'll also make the presentation available for yourself to recap what was covered and to share with your colleagues. I will be I'll be in communication with you on the chat, and I'll be looking out for any questions that you might have. Please feel free to post any questions, which we will address during the Q&A session at the end of the presentation. So for now, I'd like to hand over to our presenter, Christophe Lepage. Thank you very much, Christophe.
Okay, good morning, Johan, and good morning to our attendees. Yes, thank you for the introduction, Johan. And today's topic, we're going to be discussing the Ioke. So it's an industrial IoT device, and we see it as a key to the industrial IoT applications. It's an exciting new product for us. So, and yeah, unofficially, this product is still going to be launched very soon. So you're obviously seeing something that is still in the launching phase, but definitely something to be excited about. I'd like to officially introduce myself to everyone. My name is Christophe Lepage, and I'm the Business Development Manager for the industrial networking range of products, such as Iolink and ASI. I've been with IFM for the last 6 years, and I look forward to present this topic to you today. So let's have a look at our agenda. And on our agenda today, very quick, very basic. We're not going to jump into too much detail, but let's have a look at actually what the Ioke device actually is. Then we're going to have a look at the features and how the Ioke device works. We'll have a look at the cloud platform. So the Ioke is reporting to a cloud platform, and we'll have a quick look at how the cloud platform actually looks and what can we do from the platform. Then we will look at a few benefits and applications. And lastly, as mentioned, we will jump into a few questions and try to answer these questions for you. So without wasting any further time, let's have a look. What is the Ioke? So really for us, it's one of the easiest ways to bring sensors or bring sensor information down from sensor level up into a cloud-based system. So really, it is an all-round package that really consists of 3 very important things. The first thing is our gateway, which obviously is connected to a sensor. We have got a cloud-based platform where we do dashboarding and training of this information from the sensor. And lastly, what is very important is a data connection or a subscription so that the Ioke can actually transmit this data up into the cloud. So these 3 components make it possible to receive data from a sensor into the cloud onto a dashboard in probably less than a minute of setup and installation. So I'm going to try to show you why it takes less than a minute of setup and installation to actually utilize the Ioke for applications. So one thing that we always have to look at before we really feature a product is have a look at the current situation in the market and what is the problem with current IoT or remote applications or remote cloud solutions these days. So centralized monitoring of sensor data from decentralized remote applications can actually be quite difficult. And there's a few reasons why. So the first one is high, maybe initial investment costs. So equipment is quite expensive. There's always complicated wiring, there's complicated hardware, there's complexity in setting up devices and actually commissioning the entire devices from field device up into the cloud, creating a dashboard, and this can take quite a lot of time. And lastly, when we deal with remote applications with IoT and cloud-based solutions, normally there's some complex data plans and expensive tariffs. So with the Ioke, really we try to overcome these types of difficulties with a simple plug-and-play methodology. So I said earlier, it should take you less than a minute to set this up. And this is what we are trying to achieve. So if you can really take a plug and connect it into a socket, then you can actually set up an Ioke device and read the information in the cloud. That's how simple it really is. Okay, so having a look at some features of the Ioke. The Ioke really is just a Iolink master that supports 2 Iolink ports, and it has got GSM or LTE capability. Okay, so when we talk about GSM LTE, it's able to do 2G, LTE, and narrowband IoT platforms. It comes with a pre-installed SIM card. So we are trying to make this simple for you. There's a SIM card already inside the unit. We make use of a SIM card from a service provider called BICS or BICS, which is quite interesting because this SIM card we can use around the world because it is supported by over 478 network operators around the world. So wherever the Ioke is utilized around the world, generally it should work. Okay, then we have the two iLink ports connected on the unit as mentioned earlier. This is our interfacing to the sensor. Then additionally, at the bottom of the unit, there is a M12 power supply port for 24 volt DC. And also on this power supply port, there is the option for two digital outputs that are sitting on pin 2 and pin 4. Okay, so we would normally use these digital outputs for switching something like a warning light or a relay, but the functionality is there to do this. Again, the Ioke is not used for controls and switching of outputs independently. We try to limit the switching outputs remotely because it can actually cause a very dangerous situation. Okay, so the Ioke also comes in a IP65 robust housing. So for outdoor applications, for easy mounting outdoors, but this also makes it very flexible with different types of environments and different applications where the environments can be quite dusty or dirty or even wet. Okay, then we also have status LEDs on the Ioke. These LEDs are utilized for indicating to us if there's power on the unit, if there's network connectivity, and also the status of our sensors connectivity to the cloud. So there's two LEDs for the sensors. If these LEDs are on, then we know that we've got connection to the cloud for these two sensors. And lastly, there is no need for any additional configuration or setting of the Ioke. So there's no extra interfaces. There's no way to connect to the Ioke externally. Everything is pre-configured on the Ioke and via the cloud platform. So basically, powering up this unit, it will function straight away and make connection to the cloud. How does actually all of this really work? So firstly, we power the unit up. The Ioke will try to connect to the local networks in our region. It will identify which network is best suited and actually then start or establish a connection to the cloud. So once a connection to the cloud is established, the Ioke then needs to read the sensor ID that is connected to the iLink port. So an iLink sensor provides us an ID, and this ID is then transmitted to the cloud. The cloud will then actually search for what we call a IODD file from a database. Now, the IODD file is a device description file for the sensor. It explains a bit about the sensor and how to manipulate or actually interrogate the process values from the sensor. So it's quite important that we know what type of sensor it is that's connected and what type of data it's actually broadcasting. Okay, so once the IODD connection or the IODD has been found, it's been loaded into the cloud, the next step is the cloud will then start requesting the sensor's process values on a subscribed transmission rate and start saving it in the cloud. So a subscribed transmission rate, when you purchase the Ioke, you'll purchase a subscription or data subscription for the Ioke. There's 4 types of packages that we offer. For example, if you only want to read a process value once per day, those would be for applications like monitoring water level, maybe in a dam or in a borehole or something like that, where it's not very critical. Once per hour, a bit more critical, once per minute, and then once every 10 seconds. So once every 10 seconds is the fastest update rate that you will get from the Ioke at this stage, due to there's quite an involved process for the sensor data to make its way through the Ioke, through the network to the cloud, and there's obviously some latency time that's involved with that. So once every 10 seconds is guaranteed. Anything less than that cannot be guaranteed sometimes. So at this stage, we are happy with once every 10 seconds, and this is the fastest rate that we are offering. And then once the process values are coming through, you can log on to the cloud using a web browser. from there you can actually train the values, you can look at the process values, you can create alarms. From these alarms, you can create actions such as sending an email out or sending SMS alerts out to different users. And also you can create actions based on these alarms to, for example, switch the outputs on board the Ioke to switch on a warning lamp or to switch on the relay or whatever is actually required for your operation. Okay, so it's quite simple. All of this, the most difficult part for anyone that's working this Ioke really is to basically connect the sensor and power up the unit. Everything else happens automatically. So why have we chosen IO-Link for our communication protocol on the Ioke device? It's actually quite simple to explain. IO-Link is a new solution for connection of sensors and actuators. IO-Link has been actually around for quite a while, but it's starting to become very predominant in the industry. It's starting to really shine through with its features and benefits. So the IO-Link principle between sensor and IO-Link port is based on a point-to-point bidirectional connection between the IO-Link master and the sensor. So communication works both ways, and this communication is based on what we call digitalized or binary signals. And this signal can be up to 32 bytes big. So this digitalized signal allows the transfer of a few important things for us: process data from the sensor. So some sensors, for example, might offer more than one process value, for example, flow and temperature, and that is sitting inside this digitalized signal. We can transfer parameters on IO-Link from the sensor, and we can also transfer events and diagnostics for fault finding and real-time maintenance type of approach when we're dealing with sensors. Okay, and the other thing that's quite important with IO-Link is that the IO-Link wiring layout has been standardized. So no matter what type of IO-Link sensor you have, no matter what type of IO-Link port or master you have, the pin layout should be the same. So pin 1 and 3 will be for your power supply, and pin 4 will be for IO-Link communication. So this means any IO-Link sensor that I connect onto the Ioke will always use the same pin layout. There's no need for different types of cables between sensor and Ioke or the IO-Link port. You can always use the same type of standardized cable. So it makes life much easier. And if you are using a standardized cable, you don't need to change the wiring for any reason. If you're doing, for example, analogs, where you have 2-wire or 3-wire, 4-wire type of analog combinations. Okay, so having a closer look at a Ioke signal. This is really what we are talking about when we really want to say that the Ioke is plug and play. Demonstrated here on this slide, we have an IFM, a little mag flow meter that talks Ioke, and you can see that this mag flow meter can talk 6 words of data. So it's a digitalized signal. It's 6 words of data essentially inside the signal. And what is it sending through? Well, the first 2 words that we have there is totalizer value from this mag flow. Then on the 3rd word, we have the flow value. So that's our instantaneous flow right now that the flow meter is exposed to. On the 5th word, for example, there we have temperature value. So this is the temperature of the medium that is flowing through the mag flow. And then on the last little word, we can have, for example, device status, as well as our switching signals from the sensor. So if I've set up any switch points, those will be present as well inside this entire digitalized 6 words of data that we are sending through. So you can imagine different types of Ioke sensors will have different data structures. So this is an example of a mag flow, but a pressure sensor might be different. A conductivity sensor might offer something different. Just a standard temperature sensor might offer something different. So for this reason, we have to look at the IODD file for the sensor. So the Ioke, once a connection is established, the Ioke will look at the sensor's ID and look for an IODD file for the sensor. Now we look for the IODD file online. So the cloud will look for an IODD file on the IODD Finder database. And once it locates the IODD file, it will then make connection to the sensor and start reading its process values, because now it knows how to interpret the data. And that really is what makes it plug and play. So the sensor itself, there's nothing we need to really set up. These process values from an IO-Link sensor are normally representation of the direct measurement taking place within the sensor. So there's no need for any scaling or parameterization of the sensor to actually read the process values. But what happens if we do not locate the IODD finder in the database? Because sensors are constantly being released on the market. Not everyone's updating their IODD files into the IODD finder database. So what can happen is that sometimes we can connect a sensor that is where the IODD finder of the IODD file is not present in the database yet. It is possible, obviously, to upload a IODD file manually into the cloud if required, and that also is just an extra step that we need to implement to actually commission the Ioke, but it is very easy to do this. Okay, so having a look at the cloud platform, once you've actually start working with the Ioke, you'll have access to what we call the IFM cloud. In this cloud, when you log onto the cloud, it is a web page. So you will be met with what we call a landing page or a landing screen where you're required to put in your login credentials. But obviously, there's some security. We don't want everyone to log into everyone else's accounts. But when you purchase an Ioke for the first time, you will be able to choose your own URL or web page address. So as you can see, I've highlighted the address there on my screen here. You'll see it's ifmsouthafrica.ioke.ifm. This specific address I've chosen for our IFM offices here in South Africa, but you could, for example, choose to name this your own organization's name, or you could give it your own ambiguous application name. It's really up to you. And all the Iokes that you purchase can either be registered under that specific URL, or you can create a different URL or web page address for different Iokes. It's really up to you. How do we open the web the cloud using a web browser? Any PC can do this as long as it's got internet connection. You can open the web page using a cell phone as long as it has a web browser, and then you'll have access into the cloud. Okay, so having a closer look at the cloud platform. Once logged in, you'll arrive at the landing screen or the landing cockpit screen of this cloud. You'll see that it's got a very modern look and feel and layout, which makes it very attractive and quite easy to work with. And on the left-hand side, you'll see that there's a device tree and a toolbar on the left where you've got different options and things you can select. So the first thing you'll see on my screenshot there is that I've got an Ioke on the left-hand side. It's got two sensors connected. You'll see the little green dots indicating that the sensors are actually live. And you can list all the different Iokes in your account on the left-hand side. You can give them different names. You can give the sensors different names. It's really up to you to customize this the way you want to. The next thing you'll see, if you scroll a bit down and have a look a bit down on the device tree, there's an IODD repository where you can upload IODDs. There's also some alarm history and management. So any alarms generated are historically saved. You can manage these alarms, you can clear them, you can accept them. You can even create actions based on alarms if you want to. For example, if you want to send an email out if there's an alarm that's been generated. There's some configuration and account settings, so you can have a look at your account and configuration specific to your subscription. There's an area where you can set up different users and permissions for different users. So sometimes you would like to have 5 different colleagues using the Ioke platform for their needs. So you might want to create 5 different accounts with different login credentials and set administrator permissions for the different users. So maybe some users should not be allowed to make changes to the dashboard and some can. That's really up to you to set up how you'd like this to work for you. Okay, and then there's the option to set up export of trends and data. You can do an export instantaneously, select a sensor, do an export of the data, select the time period to a CSV file, for example, or text file. But you can also schedule exports. So once a week, you'd like a specific export to take place on a sensor for a specific time zone, and you would like this export to be emailed to you directly. Okay, so you can set this up on a scheduled base if you want to. Yeah, and lastly, we have what we call the device status for the Ioke. So the device status just gives us some critical information on the Ioke device, such as signal strength and which network operator it's currently logged into, the uptime and how well it's been performing over the last couple of days or weeks or months. But yeah, it is quite important to know what your device has actually been doing. Okay, so once we select a sensor, you'll be met with a auto-generated dashboard with windows and little widgets. This is obviously auto-populated for you. How does it auto-populate this? Based on the IODD file. So the IODD file explains how the cloud must interpret this data, and it will present this data to you in a way that we can actually understand it and read it. So the first thing that's quite nice is a general information window on the sensor that's connected. In this window, you'll get the name of the sensor. You can change the sensor name to an application tag name if you'd like to. Which port of the Ioke device the sensor is connected to, the vendor ID, the sensor ID, who is the supplier of the sensor, for example, if it's an IFM sensor, and also the communication status. So when last was a process value actually updated to the cloud from this specific sensor. Then on the right hand side, again, specific to the sensor, we have got an alarm list or history list. So if there's any alarms or historical events that have taken place on the sensor, they will be present in this auto-populated widget for you. And then in the middle of the screen is our first process value. So this little temperature sensor connected here, the IODD file has identified that the temperature sensor is going to offer us temperature and switching signal. So the first process value is our temperature here. It's a live animated widget that is populated with a live trend graph. You can access this trend graph, change the scaling, change the time period. You can zoom in on this graph if you'd like to. And on the right-hand side of this little animated window is what we call cloud operations. So cloud operations, we can configure thresholds. If a temperature goes too high, I would like an alarm to be generated, and then I would like an action to take place. For example, email certain users or certain email addresses, or send an SMS to certain users or relevant people that actually need to know this. Or you could switch an output on the Ioke. So if the temperature goes too high, I'd like an output to switch and signal an operator in the control room for a lamp or something like that, that the output is switched because the temperature has gone too high. Okay, and lastly, the second process value for this specific sensor, it is only a digital switching signal. So also it's a live animated widget. Currently my digital switching state is off. There's a little trend graph just to show you how the digital signal when it was on, when last was off. And again, also cloud operations, so we can create some threshold alarms if required on that specific digital signal. Okay, on the top right of this dashboard, there's a little toolbox area. This little toolbox area allows us to add extra widgets into this auto-populated page. It allows us to create new dashboards. We can change the layout, we can change the color of these dashboards. We can lock the dashboard, so then once it's locked by the administrator, and we don't want anyone else to be able to make changes here. We can enable maybe a full screen view. Full screen view would move the toolbar on the left hand side away, and then you'd have a nice full screen view of this dashboard. So I've created a example of a customized dashboard here for this same temperature sensor. I've just removed all the auto-populated widgets and I've created my own. I've added an image of a little pump. So for example, this temperature sensor is sitting on a centrifugal pump somewhere. I've created two widgets indicating the temperature for us with limits, so warning and alarm limit. And also I've blown up the trend graph to make it a bit more user-friendly for us and more relevant for our application. So they have trended it over a couple of days and you can actually see the temperature going up and down. But the trend graph is quite nice because it offers us quite a lot of functionality in the terms of if you use your mouse and hover over a trend graph, there's a little cursor that highlights a specific point in the graph that can show us the immediate time and the process value at that time. It's possible to zoom in and out of that little graph using a drag functionality of your mouse. You can scale the graph, and also you can observe these types of graphs in real time. So moving on to a few benefits and applications of the Ioke. One of the things that's quite probably on a few of our minds is what does it offer to us and what can I do with this? So the first thing is really I've tried to show you that it's an all-in-one solution for remote process monitoring. So there's a few nice features, for example, plug and play. Basically, you just need to connect the sensors, power the unit, and log into the cloud. That's the 3 steps, and you have a remote IoT application. It's very easy to use. So the cloud platform is easy to use. Connecting the sensors are standardized cables. There's no way you can actually get the wiring wrong. Very easy to set up and use. As mentioned earlier, should take you a minute to set this up and have information up in the cloud. Okay, the robust IP65 housing allows us to use this in remote areas or environments that are outside. So it's no need to mount this inside closed panels. The unit can withstand quite a few environmental hazards and aspects, so that's quite nice. Yes, and the modern creative dashboard options. So there's a lot of creative ideas you can do with dashboards and really make it your own if you'd like to. There's really no programming involved to do this. You can really log in and utilize it yourself. Again, very nice for people who are not programmers, maybe managers or data clerks who would like to log onto a dashboard to actually pull information and use it for KPIs. There's nothing that they can, if they log in, there's nothing that they will not be able to understand or use on the dashboards. Yeah, really doesn't require any existing infrastructure. I mean, if you've got 24 volts present, you can really use the Ioke there already. Okay, so the Ioke also can achieve or help you achieve higher machine uptime by monitoring critical values. So some applications you can apply to, for example, machines and plants, pumps, different types of tanks and fans. So really the applications are really endless. If you apply the Ioke, yes, you can monitor these critical values, you can achieve higher machine uptime, but really every application is different, but the possibilities are definitely there. Okay, and another thing that's quite nice, with the Ioke, you can reduce operating costs by logging key performance indicators. Okay, so for example, if you're looking for a solution to do some water monitoring in remote areas, or you don't have infrastructure, you don't want to connect it to your PLC, this is one very easy way to do that. Energy monitoring, maybe air monitoring, compressed air usage, production count. You can really use this device anywhere, and it can really assist you with logging performance key indicators and reducing operating costs and achieving high machine uptime. So yeah, the application's all there, the Ioke can do it. Yeah, so these are some simple basic benefits. Obviously, there's many more that we can list, but I'm not going to spend too much time on that. But a few questions generally posed when we look at the Ioke is, what about traditional analog sensors? Maybe I don't want to use Iot sensors. Maybe I already have sensors in my plant. Yeah, look, it's not a problem. We are only using the Iot principle here, but we can collect these analog sensors. So how we do this, there's a few ways we can do this. One example is our inline conversion plug. We can take a 4 to 20 milliamp sensor, plug a little conversion plug in between the sensor and the Ioke, and convert the 4 to 20 milliamps to Ioke. The same applies for 0 to 10 volts or 0 to 20 milliamps. These conversion plugs are readily available in the market to do this for you. And also, as stated before, there's 2 Ioke ports here, not just one. So we could actually do 2 sensors onto the Ioke in this case. So this is one way. A second way to do this would be to make use of what we call the Multiport Ioke expansion module, which allows us really to connect up to 8 analog sensors on a multi-port unit. But we also have expansion modules that can, for example, do 20 digital in. So you can imagine if we double this up, I could do 40 digital inputs on the Ioke, or I could do 16 analog inputs using these expansion modules. So this is an example of a multi-port expansion module. You'll notice that there's 8 4 to 20 milliamp sensors connected onto this module, and this module just basically talks Ioke to the Ioke. The Ioke will pick up the Ioke communication. It will get the IODD file, and it will interpret all these 4 to 20 milliamp sensors in the cloud. And then from on the cloud, you'll be able to scale that 4 to 20 milliamp signal to a 0 to 100% signal, whatever scaling you'd like to actually use for the specific sensor, and apply it on your dashboards. As mentioned earlier, we could connect 2 of these devices because we have 2 Ioke ports available on the Ioke. So we could really connect 16 analog sensors to the Ioke if we wanted to. And lastly, what if I wanted to connect the Ioke into an existing loop? that is ready between a sensor and a PLC. I would like to make a specific unique sensor remote monitoring possible. So I already have some sensors out in my plant, and I would like these sensors to become or be utilized in a remote monitoring application. So we make use of what we call the data splitter plug in this case. We connect this plug in line with the loop by making use of a Y connection, and then the data splitter then passes the 4 to 20 milliamp signal back on the Y connection to the PLC or switching signal or a 0 to 10 volt signal, and on the other side of the data splitter we will talk Ioke to the Ioke device. Okay, so it's quite easy to implement this. Obviously, it's just a bit of extra wiring, but the solutions are there to do this. Yeah, so different types of applications. Really, you can monitor anything anywhere, as long as there's obviously network coverage. But really, our unique applications would be areas that are remote, or there's limited infrastructure. Then the Ioke would really shine for you. So places like remote dams or borehole applications out in agricultural fields, remote panels. So there's been quite a number of requests from a few of our customers for doing or monitoring panels remotely for security purposes. If the panel doors open, I would like to send an email or SMS to people to let them know that the panel's been opened out in the field. Maybe someone's tampering with the panel, or yeah, trying to damage it, or whatever the case is. So the Ioke could be installed, and it could send you an alarm. Cement silos, we know cement silos generally don't have a lot of infrastructure, and you'd be able to monitor level in these cement silos or these types of difficult applications where there's very little infrastructure in terms of automation. Remote pump house stations, also, yeah, there's quite a number of applications we've had with remote monitoring on pump house stations, only of the critical process values that are required. But another key area for applications is service providers. So normally we make use of service providers to deliver us a specific service or product. These service providers could utilize the Ioke to their benefit. For example, portable toilets. Normally these types of toilets are serviced on a schedule, once a week or once a couple of days. Maybe in some areas once a couple of months, but yeah, sorry about that. But why would we want to send a truck out to service the toilet if the toilet hasn't been utilized, if it's not ready to be serviced? So the truck drives all the way there, only to realize that there was no need for the truck to drive there. So we could install an Ioke and monitor these toilets, and then the service provider would know, when should I send the truck out? Another example is tanks or diesel tanks. Normally also serviced possibly on a routine basis. The truck drives all the way out to fill the tank. What if the tank's still full? What if the truck didn't need to drive all the way there? The service provider could have utilized a remote monitoring device like the Ioke to monitor the tank and only send out the truck when it really needed to go there. So, excuse me. So there's a lot of applications for service providers as well. And yeah, I've just listed a few that popped into my head. But again, if you do have some applications, please speak to us and let's see if the Ioke would work for you. So lastly, in terms of some expanded functionality of the Ioke device, I've mentioned earlier, all this data comes through from the Ioke into the IFM cloud. Can we take this data and take it out the cloud and utilize it elsewhere other than the export function into CSV or text file? Yes, luckily it is possible. We can make use of, for example, Node-RED or Analytics Builder. Also, two very nice softwares that offer us a lot of features. And for example, with Node-RED, I have done a few testing and I've played around with the Node-RED. It is possible to interrogate the cloud, pull information from the IFM cloud about, or from these processed data from the cloud into Node-RED and utilize it in Node-RED for different channels, such as maybe MQTT services. If you want to maybe push the data into your own database like SQL. Maybe you want to take this data from the Ioke and put it into your PLC for whatever reason. Maybe you would like to use your own email functionality on Node-RED, or when a critical threshold value has been exceeded, an alarm is generated, I would like to send a WhatsApp to people. So Node-RED you can set up Node-RED to actually send WhatsApps. So there's a lot of benefits to the expanded functionality, and this just shows you that we do not lock the data in the IFM cloud and then you cannot utilize it. You can still utilize this data for other areas and other applications if you'd like to do that. Yeah, so in conclusion, I mean, sure, the Ioke can help you unlock possibilities that possibly were not quite easily achievable before in terms of remote applications or IoT applications. And we really do feel that it is one of the simplest ways to achieve IoT or remote monitoring. So the slogan here really speaks for itself, no matter where and no matter what, you can just really measure it. Yeah, so from my side, that is the end of the presentation. I would like to hand over to Johan. If there's any questions that have been posted, I can maybe answer. We still have a bit of time. Johan?
Hi, Christoph. Thank you very much for the presentation. And also thank you very much for the audience. There was a lot of communication happening and a lot of questions being asked. So I'm going to try and address a few questions, Christoph. It's not going to be in order. It's as I try to capture them during the Q&A session. But one question that came up quite often is IFM looking at a battery-powered Ioke in future?
Yes, so at this stage, we do not have a solution for any battery-powered Ioke. I mean, we could obviously approach a few different suppliers for batteries and maybe a solar panel to charge the battery for remote areas. So it is definitely possible. As soon as this product is officially launched in South Africa, we will look at maybe a few suppliers and see if we can tailor-make an entire package solution for any customer that is looking for an entire solution. So, but from IFM's side, we do not offer any batteries or any additional accessories for the Ioke in terms of power supplying.
Perfect, thank you. Then one question we had is, when an alarm occurs, can a cloud program send you an email or an SMS to an operator?
Yes, so as mentioned in the presentation, you can create your own threshold alarms. If the alarm is triggered, you can send an email or SMS to different users with different email addresses as required. So you just have to set this up. As well as in terms of threshold alarms, if a sensor has been disconnected, it also creates an alarm. You could also send an alarm to say sensor has been disconnected from the Ioke.
Good. Then obviously the sensor response time is dependent on the sample package that you choose.
Yes, yes it is. So we have the four options of once per day, once per hour, once per minute, or once every 10 seconds. So depending on your application, would determine really what type of package would be suited for you. Sometimes in some applications, you don't need to get a reading every 10 seconds. Maybe you only need a reading once every hour because your process changes very slowly. So yeah, we would definitely look at that and then determine which package works best.
Thank you, Christoph. Then another power question is, can the Ioke be powered by power over Ethernet?
So the Ioke does not have any Ethernet functionality or any Ethernet port. So it would not be possible to do power over Ethernet, no. So it's only 24-volt DC supply.
Thank you. And then you did mention SQL at the end, but can the Ioke push data to SQL DB?
Yes, yes. So we would utilize, for example, Node-RED to do that. But I can also we can also look at other platforms that can interrogate the IFM cloud. But at this stage, the only one I've really tested and played with is with Node-RED.
Okay, thank you very much. There's quite a few questions still left, so I'm trying to cover a few of them. So do I need an external antenna if I install the unit somewhere like in a panel?
Okay, so the unit has got a built-in antenna internally, similar to your cell phone or your modern cell phone these days. There's no need for an external antenna. Obviously, the limitation then is that I would not be able to mount the Ioke inside a closed panel because there's a chance that once the panel door is closed, there's no network coverage inside your panel. For that reason, the Ioke has got the IP65 housing to mount it outside the panel. But to answer the question, no, there's no need for an external antenna. The antenna's internally inside the Ioke.
Okay, so I've got about 4 more questions I think we need to cover today. And I think the next one is, how much data will be used on a monthly basis when our unit transmit data for every minute? And I think the real question is basically, can the unit be set up in such a way that I can only receive messages like events like a high level, or does it only send data on cyclic basis?
Okay, so there's 2 parts to this type of question. How much data is sent once every hour really depends on the type of sensor connected, because each sensor talks a different amount of data. So for example, if the sensor talks 6 words of data, then that's how much it will send once every hour. But coming back to the subscriptions, this is the second part of the question for us. We do not charge a tariff for the amount of data usage. What we are doing in terms of subscription is you purchase the Ioke and you purchase a subscription that it will upload the data to the cloud once every hour, irrespective of how much data it is. So we do not charge you for data usage. We're only charging you for the type of subscription you are going to apply for.
Thank you, Christopher. And I think a follow-up question that we have is, do you have to transmit a complete IODD file, or can you have specific information being selected?
Yeah, so with the IODD file, you will have to, you're not going to be selective in the data. It comes back to the earlier question in terms of how much data is sent. The iLink principle works on the fact that it needs to send the entire packet of data that the sensor is able to talk over iLink. So if the sensor can talk 6 words, it has to send 6 words. We cannot only send a portion of that message, because then the Ioke will not know how to interpret that. That is just the way that the iLink principle works. But as mentioned in an earlier question, we're not really concerned on the payload of data that we are sending through, because we are not charging the customer for data usage. It is just on a subscription basis, once every day, once every hour, once every minute, and that is what you will pay for.
Thank you, Christoph. 2 more questions. Is the dashboard progressive web app ready, or is there a mobile application available?
Mobile application.
So I think what they're trying to ask specifically is for cell phone apps.
Yeah, at this stage, I'm not aware of any development from our IFM departments for a app. At this stage, it is purely based on the web application, but I will have to do a follow-up on that, because there is, I think maybe a few of our attendees are aware of a new product that we've launched called Moneo software. There is a drive at the stage to connect the Ioke into what we call the Moneo platform, and there is a Moneo app available for cell phones. So I speak in the correction. I'll definitely look up further information on this topic, but as soon as something is available, we'll obviously be communicating this to our customers and our attendees, that yes, there will, if there is something or it isn't, but I will post the answer to this question once I've looked up a bit more information. So after this Q&A session, we capture all these questions and we create a PDF document that is available on our website. I will post the answer once I have it on this PDF document.
Thank you, Christoph. And then the last question is, are IFM looking to expand the Ioke so that we can accept more than 2 IO-Link sensors in future?
Yes, so also at this stage, it's difficult for me to answer that. I'm not 100% sure what the development is in terms of Ioke. This topic has been brought up by a number of our colleagues around the world, that they would like to do more than 2 Ioke ports. And I'm quite sure that our R&D department and product managers that manage this product have definitely looked into this. At this stage, I have not seen any concrete answer to that. I would believe so, yes, they would like to do something like that in the future to make it more flexible and obviously to get more out of the product, but definitely not something in the very short term at this stage to implement. Yeah, so again, to answer this question, I'll definitely have to have a bit of a research session and see what the roadmap is for the product, and I'll be able to post that answer, a more concrete and definite answer after the presentation on the Q&A document, and see if I can get more information on for you.
Thank you, Christoph. I can see there's a lot of more questions coming in. So unfortunately, we will not be able to answer all the questions. So have a look out for the Q&A document that will be on our website. I think just lastly, very important to understand that this product was developed for remote applications and unique applications. So once we move into more information required, I think there is alternative options available from IFM to do a complete solution in this area. So thank you very much for attending. From the Q&A session, that's all from my side. I'm going to hand over back to Christoph to finish the presentation, and thank you very much for attending.
Okay, so thank you, Jan. Yes, and thank you to the attendees and the questions that have been posted. Some of the questions definitely have quite interesting, have boggled my mind a bit, but yeah, we'll answer all these questions on the document. Have a look out on our website, and then if there's any further questions, please feel free to contact us. Yeah, so today, basically, I've covered a few various topics for you on a very basic level, but I always would encourage you to contact your nearest IFM office, or your nearest or your sales representative, sales engineer in your area, if you'd like to get more information on this. As mentioned, the Ioke is still set to be launched in South Africa, so you are seeing something that's you're the first audience to actually see this product, or this discussion about this product. So yeah, as soon as it's launched, everyone will be made aware. There will be obviously some marketing material, and our sales engineers will start discussing this product at your organizations. But you're also more than welcome to follow us on different social media platforms for more information about the Ioke, about different products and innovation ideas. We are available on YouTube and Facebook, Twitter, LinkedIn, Instagram, to name a few. So definitely worth having a look. Yeah, so also this webinar forms part of a series of webinars we've been doing. If you're interested to see what else is offered on our webinars, you can log on to our IFM homepage, and you'll see right in the middle of the homepage is this little webinar icon. You can click on this icon and register for any upcoming webinars. There's still a number of topics that we would like to cover this year. Yeah, so please feel free to do that. And then lastly, yes, from my side, I would like to thank everyone that has attended and participated in this little webinar of ours. Definitely brings excitement to me knowing that there's so many attendees interested in technology and new developments. Yeah, and lastly, from my side, I would like to wish everyone a safe day and a great day going forward. Once again, thank you very much, and yeah, all the best. Thank you.